Okay, welcome back to the 30-day scripting challenge. It's been a pretty long time since I made a video. It's day 17 right now. I made day 6, I think, 2 weeks ago. I've been one of the busiest people ever right now with a lot of things going on with school, but I'm trying to find as much time to fit in one of these 30-day scripting challenge videos because they're a lot longer than I thought. They're getting longer to make now because things are getting more and more advanced. Speaking of which, day 17 is going to get into object-oriented programming, and it's something a lot of people don't understand how to use. So I'm gonna try to keep this as simple as I can, especially since this is only, I believe, week 3 or something. Or, yeah, it's week 3, I believe. So we're gonna start by, actually, let me talk about the setup I made here. I just made a folder called turret field, and then I probably should just call it tower fielder because it'll be a tower system, and then a folder called spawn, and then a part called spawn area. And I'll talk more about this in a second here. I don't like this commenting mode thing that they added. I mean, I get it's nice, but Discord and stuff is better for community, whatever. And we're pretty much just gonna spawn towers on this tower field here. And in this case, I've used Hidden Tesla from Clash Royale. This is just a free model that I found. We're going to be using this as our tower here, so I have that in our little folder called assets and replicate storage. Now, let's move on here. We're going to go into our shared folder, and we're going to make a class. And pretty much a class is kind of something that we can assign to an object, and it'll allow us to give it properties. So in this case, we're going to use it to give custom signals to our tower, which will be an event where the player enters the range and where the player leaves the range. So we're going to make a module here. Now, I would create a separate folder for classes, but I'm just going to keep it simple and put it in this module thing here. This type of architecture, the service-based hybrid, it's not really the best, but it's kind of simple to have all of them in one area so you could see your scripts better. Usually you would spread these out into starter player, starter GUI, server script service, and replicated storage, but anyways, we're just going to make a class. So the way you would make a class is you'd use Roblox Studio's meta table pattern, and we'd use it to define a tower class here. So I'll call this tower, and we're going to, on this second line here, we're going to do something called tower.index. So you do underscore and then index, and we'll have that set to the tower. And you would do this for object-oriented programming. Now, I don't want to make this entire video a tutorial on object-oriented programming. I want to make it about the tower system that we're going to use object-oriented programming for. And then we're going to make a function, which will just be Tower.new, and this will be how we're going to create our tower. In this case, I'd want to create a new tower, and then have it be randomly placed somewhere in this tower field here. So what I would probably do is just have a range value passed, or actually probably no information would be passed here other than what type of tower we're gonna create. But this will be for our parent tower, there will be different towers that you could create from this, like a sniper tower or a bomb tower, Clash Royale reference. But we're gonna pass in the position that we want the tower to spawn in. So we'll have that be in there. And then we can also probably put in a range value too, which I would probably just store in the tower itself, but we could put that in if we needed to. And now we're gonna work on the rest of the object-oriented setup. So it'll be, we would do this thing called local self is going to equal to, and then we're going to run this set meta table command here. And why did I go to insert? And then we're going to put in our table here, and then our new meta, which will just be the tower thing right here. It'll be this. And this is pretty much the basic setup of an object-oriented programming class. It's kind of something that I might get into later on in the series, but for week 3 right now, I want to keep it as simple as I can. And then we're gonna run the rest of our data. So we'll say self dot position is going to actually maybe we'll do self dot position is going to equal to our position to value here, and then we'll do self dot range is going to equal to the range value. And then we'll do self.model. In this case, it's going to be whatever model we want. So we're going to go into replicated storage into our assets, and we're going to clone the tower. So the script.parent assets dot tower clone, and then we'll do self.model pivot to, actually no, we're not going to do that, or honestly maybe we should pivot to, and then our cframe, so cframe and .new, and we're just going to put in the position here. I probably should actually change the parent too, so we'll just do, wait, let me do that here. It will be workspace dot tower field dot spawn. Okay, now that we have our our physical data set up here, we're now going to work on the signals. So pretty much a signal is, you definitely seen this before. It's like if we have a part and the part would have something like dart touched connect, right? This would be a signal because it's kind of like we would connect to this signal every time the part has been touched, right? We're gonna create our own custom signal for this tower here. In this case, the way you do it, so we're gonna create our own custom signals here by using a new module. So I'll just make another module script here, and it's going to be for creating signals here. So I'm just gonna call this one signal. Now this is where things are gonna get a little tiny bit confusing, because signals are also gonna run on object-oriented programming. But we're gonna do the same thing we did in that tower script. We're going to say signal.index is going to equal to signal, and then we're going to do function signal.new. This is going to create our signal, in which case we're going to run that local self is going to equal to set meta table, give it the table, and then the new meta right there. And then we're going to do another thing, which is going to be self.underscore, I like to call this connections, right? And it's going to equal to a table here, because this is going to be everything that's connected to the signal, right? And then we're going to return the meta table here, right? We're going to return that. Now we're going to do the connect function. So what we're going to connect the thing to, so function signal connect, and then in this case our function, which we can type in as fn or just function or whatever. Actually no, right? And then there's going to be a function that we can use called assert, and pretty much what an assert will do is it'll give us an error if whatever we provide is false or nil. And if the assertion, if it goes through with it, then it returns everything that was passed to it. So we're going to run the assert thing. So if there's an error that provide value resolved to false or nil, and we're going to run assert, and we're going to check if this fn here is a function or not. So we're going to use this thing called type of, which will tell us if this is a function or not. So if the type of fn is equal to a function, and then we will put in our error message here, which in this case con must be a function, right? So our first value is going to be our check to see if this is not false, and if it is false, it'll throw us this error message saying the connection must be a function, right? And that's the assert thing right here. And now that that's done, we'll know the rest of the code will work. So we'll say local connection, and I'm gonna try not to explain this because I think it might overcomplicate it, but I will link some important resources about object-oriented programming in the description. But we're going to give the connection a table in which we're going to have our function in. So we will do underscore function is going to equal to, wait, what am I doing? It's going to equal to the function, and then we're going to have underscore connected is going to equal to true. And anyways, right, this f in here, this is our callback function. And if you know when we did the timer service thing here, we had a callback function here that we would call when the timer had finished. Anyways, right, each of these connections, we represent with a table, right? And it has its own state, the connected value. In this case, we'll know that this connection has been connected to. Anyways, we're now going to make a method to disconnect it. So we'll just do function connection disconnect, disconnect right here, and we're going to do this so that way when the thing is like done, when like the connection has finished, we can disconnect it, right? Or whenever we need to disconnect it. That's like when we do a run service, right? We say like local con, and then not con, we'll say the con is going to run service dot render step colon, like that, and then we do like con colon disconnect when we need to end it, right? Sorry, that's a very bad example, but that's what this disconnect thing will be here for. And all it's going to do is it's going to set the connected to equal false. And also, I forgot to say this, but we put the underscore in front of some of these things because it will show that they're like internal, that these are private things that are not really meant to be accessed from outside of the code. They're only meant to be like private and internal. And then after we have this, I keep saying and then like so much, it's pissing me off. We're going to insert the connection into this table here. So we can just say table.insert self underscore connections, the connection right here. We're gonna put this inside of our signals connections table right here. And once it's done, we can just return the connection. And that's it right here. This is our colon connect function here. And then our next one we're going to do is the fire, which will let us know when our script can receive it. I'm explaining this really poorly, but hopefully this makes sense to some people. So we'll do function signal colon fire. So this will be like the part telling the listener that the part has been touched, right? So also we're gonna put in these three dots represent it kind of acts as like a table that we can use to send in all of our arguments in. So in this case you can have a lot of them. You can have one, you can have anyways, right? We're gonna iterate over all of the listeners that have this signal connected to it. Not connected, but that are listening to it, right? So we'll just do for underscore connection in, and you could use I-pairs, which is iterator pairs, to get everything like ordered, or you could just like keep it out. I-pairs kind of keeps things organized from like all the listeners, but in regular just did stuff.connections, it would go through like all of them in any order. I'm not going to use pairs. I don't really tend to use them a lot. Only in like very few like loops would I use pairs or I-pairs. But we're going to do just regular, because a for IV in thing loop, it only needs to loop through a table. You wouldn't need to do pairs a lot unless you want the loop to be ordered in some way. Anyways, we're going to now trigger, what am I doing? We're only going to like trigger this connection if it's still like active. I said that so bad, but like you'll see what I mean. So if connection dot connected, then so if we disconnected, then we'll use test of spawn here, and we're gonna run the callback right as our function, and then we're going to put in our what the hell? Why did I go out of full screen? We're gonna put in the three dots here, right? The variable is passed, and this will pretty much just run asynchronously. My English is terrible. And actually, to keep things simple, we can change this to just be called callback instead of a function, in case anyone might get confused there. Because I also changed this to callback, so it wouldn't work if this was called fn and this was called callback. Okay, now we're going to do our signal colon wait here. Like signals have like a 4-part thing: the connect, the fire, the wait, and then the end. So we already did 2 of the events for the signal. We're now going to do the signal colon wait here. So we'll just do function and then signal colon wait. And in here we're gonna use coroutines, and we're gonna use a method called coroutine dot running, and pretty much like signal dot wait. It's gonna yield our thread until the next time our signal fires, and then once that happens, it'll return the arguments that we passed to fire. Alright, and you'll need this for custom signals. So just say local thread will equal to coroutine dot running right here. Here's the thing right here, right? Coroutine dot running, which will return the running code. I'm like so dead right now. Anyways, we'll now use our local connection here, because you can now see how we'll use the connection colon disconnect thing, right? and we're going to say connection is going to equal to self, not select, well, self colon connect, and then because we have our colon connect function right here, and then we'll use the function passing in these 3 dots here. I forgot what the term for this was called. I really forgot what it was called. But what this will do is it's gonna temporarily connect to a listener that will resume when this thread's fired. In this case, we have it right here. When it's fired, it'll resume. So we'll do the connection colon disconnect, and then we're going to run our task.spawn, and we disconnect it here because we only want this to trigger once, and then we'll resume the waiting coroutine with the arguments. Right, we're gonna resume it because we don't want it to stay waiting forever. So we'll pass in our thread and then the 3 dots. Sorry if this was a little confusing, I know, but it's really nice to learn this type of thing. And we'll return the coroutine dot yield, and if you've read there, it just suspends the execution of the thread. And that's it. That's our signal colon wait here, which is what we pretty much need to like keep our things waiting, to keep our signals waiting. Yeah. And now the 4th thing is the end of our signal. So it's just going to clean up all the listeners. And it's kind of nice because if we're destroying the object that owns the signal, it's pretty useful. It's really just one line function signal colon destroy. We're just going to set connections to equal to nil. And you can also add other things in the colon destroy, but this is like literally all you need for colon destroy. And this is our signal module here. And with that, we can go back to our tower, and we can now grab the signal module here, so we can just say local signal. Actually, I don't even need to do that because I have require autocomplete. I just like snip signal here, right? And now down here we'll add in our custom signals. So we'll say self.player entered is going to equal to signal.new, and then we'll say self.player left will equal signal.new, and then we'll do self.fired will equal to signal.new. And this fired thing will be when our signals have been like fired. Kind of self-explanatory. And then we'll finish this up here by returning the self. And that's our Tower.new, right? These will be helpful for any other scripts that will create a tower, because it'll give us our player entered, player left, self-defined. And then also, I forgot, you need to put the players in range. And it'll just be a table, so we know what players are in range. And then that's it for this. We're now going to continue on with the detection logic, which will be for when a player has entered range. So as I said before, with the underscore, it's only something that needs to be local, not local, but internal. So we're going to do function tower colon then underscore to keep things local, and then it'll be like monitor players, and usually you would put your internal things as lowercase, right, like camel case, right? Anyways, we're now going to do a loop just to check all players in range. So there's a certain like time period you can wait. It's called like the CPU time, though I could be really wrong about this, but it's 0.05 seconds. And it's a fast way to like loop something that keeps your CPU like really like good. You know, it doesn't use too much of it. I forgot what it's called, but it's there. And then once you like have this loop running, you're just gonna go through all the players in the game, and we're gonna check if they're in range of our tower or not. So let's grab the players service up here. I'll just like do it here, I guess. Well, actually, you only need to use players like once here, so I don't even need to use it. We're just going to check. So for underscore player in game dot players colon get players do we'll say local character will equal to the player dot character, and then local, we'll just say HRP for short, humanoid part is going to equal to the character and character colon child humanoid root part. So you know this character and the character colon find first child, you know, it just checks that if the character does exist. So it needs the character and the humanoid root part. And here it's going to check if HRP, then we're going to now get our distance. So local distance will equal to the subtract the humanoid root part position from our self dot position here, and we're going to get the magnitude of that. So let's just get HRP dot position minus self dot position, and then we'll do dot magnitude, which will get our distance. I'm like so tired, bro. I don't know why. We're then gonna have our we're gonna create a boolean to check if we're in range. So we'll say local in range equal to, and it'll kind of be like our check here. So it'll equal to our distance, and then less than or equal to self dot range, and this will be our check to determine if our player is in range. Now we're gonna do, guessed it, if in range and not. So we're gonna need to check if the player is in range and they're not already in this table. I don't know why I friggin' did this. Well, actually, because I'm gonna include this monitor players thing in here. So and not self dot players in range player. Then we're just going to say self dot players in. Why does it not? I don't understand this. Player equal to true. So it'll literally just tell us if the player is in range. This is how we can add them into a table that will tell us if the player is in range or not. And then we'll just say self dot player entered in fire. And then we're gonna pass in the player. So in this case, player entered is a signal, and then with our signal we have signal colon fire. So we're just going to fire that signal. Now we're gonna run our else if not in range. No, what? Else if not in range and self dot players in range player. Then so if they're not in range but they're in the thing, we're just gonna set them to be no. So self dot players in range player is going to equal to nil, and then self dot player left colon fire. And that's it for our wider players thing. So now we can just have this run at the top here. So it'll be, we'll task.spawn it, and it's just going to be a self monitor players. Simple as that. And now I'm gonna try not to say and then for the rest of this video. If I do, I'm gonna cry. But we're now going to make the firing method, which will be what'll happen when a player is in range, or it'll be something that our system can use to run when our players entered the range. So we'll just say function tower colon fire. No, I'm not gonna do fire. I'll do fire to make it not get confused with our signal colon fire. And we'll need the player to fire to, so we'll simply just say local character going to equal to player dot character, and I'm going to put some type checking in here. Player, there we go. It'll be player dot character, and then we can just freaking copy this here. So if HRB, then we'll run the self dot fired colon fire player. So this fire thing will be for attacking. I'm sorry if I said that this was for firing our signals. I that I just got confused for a second. It's when you're coding something and you're writing something, you know what you're doing, but then you say something else. Hopefully I'm not the only one who does that. It might be an ADHD thing. I don't have ADHD. Surely I don't. Okay, I'm getting distracted. Oh my gosh. We're now going to create our projectile, in this case. Any other thing that you want to show that the player has entered range, In this case, I'll create a projectile to shoot at the player when they enter the range. Just say local projectile is going to equal to, in this case, I'm not going to use the bullet tracer. I'm going to create a new one, instance.new part. And then we're going to run the setup for creating a new part. So say projectile dot size, make it 0.3 or something, what's it, what would be a good size? Or is it 0.3, maybe 0.3, 0.3. Yeah, that seems like a good projectile, Maybe 0.2, because this is a Tesla, Yeah, okay, that seems good. Or we could just have the projectile be one long block. So we can why am I we'll have our projectile, right? And if we want to be a laser beam, we need to get some extra values here. So we need a starting position and an ending position. So in this case, in my model of the Tesla here, it's got a what's it right here. So this will be the beam, or we'll just call it beam, right? This is where the thing will come out of. So I'll store that somewhere. But you'd want to get that. You'd want to get the beam thing So we would get our start position of the laser beam. So local start position will equal to self dot model dot beam dot position, and then we'll say local end position will equal to the humanoid root part dot position. There, I said and then. Our direction will be the, what am I doing? It's gonna be the end position minus the start position, magnitude. Wait, no, what am I doing? No, we have to. The local distance will be the direction dot magnitude. There we go. Now here's where we're gonna continue making our part. So the size will just be. We'll probably use 0.3 honestly for the x and the y, and then our z will just be our distance variable, and then we'll just say like projectile dot anchored will equal to true projectile but can collide will equal false. We'll say projectile dot mass, no, not mass, material will equal to dot material dot neon. Then we'll just say project. I'm just gonna speed through this real quick. We're actually give it a C-frame so that way it'll face the direction that we want it to. Alright, so now we've created our projectile here. This is a simple thing to get the C-frame thing. I don't want to explain it. I'm too tired. We can add like any hit feedback here, like a print statement or like a thing to tell the player they've been hit by the laser. Or we could just do this entire logic on the client to save resources, because creating projectiles on the server is really like inefficient. And we're gonna have the projectile like fade out. So task.spawn, one of my favorite things to use. And then we'll have it fade out. Not load string, bruh. Stop! My enter key not working? Hello? Okay. So pretty much it'll loop through the transparency, and then when it's done, it's just we're gonna destroy it. Just like that. Alright, now we can go connect this to a server script. So usually you would create a service that would run through all of the entire thing. I'm just gonna make a server script. I'm gonna make a server script. This would be called like tower server on. So we'd grab our tower here, and we'll just simply say local tower will equal to Tower.new, and then we would give it a random position along this part here, so we could create a function for that. So I can show you. You would simply just store the size value right here, or actually you would just pick a random position on the part. So like, just like, oh my gosh, I'm tweaking. You'd make a function random position, and then we would use the spawn area thing. So we'll just say local like spawn area equal to workspace dot tower field dot spawn area. Say local size will equal to the spawn area dot size, and then local position will equal to the spawn area dot position. And now we just get some random offsets. So local x equal to position dot x plus, and then math dot random, which if you don't put any values does it from 0 to 1, so we'll do like minus 0.5, and then multiply it by the size dot x, so it will give us a random x value. And you'd copy this over for the y and the z values here, so y, and then z, and then return vector3 dot new x, y, and z. So it'll give us a random position on the spawn area, and then we'll pretty much just send in random position. Our range will just do like 20 slots of range, right? Alright, and now we can simply just say like tower dots. So now if we have our signals here, player entered colon connect function, and then the player that entered range, we'll just say tower colon fire at the player, and that should be it. It should be good to go. Now if I were to play test it, and now we have an error. Okay, but the tower did spawn in. You can see it right there. Oh, what's the error? Signal 20. Oh, I put 2 underscores there on accident. Oops. It should only be 1. Alright, so here we go. We have our tower, and now if I enter the range, it should, yeah, there's 1 laser beam. Okay, it needs to like repeatedly fire at me. Okay, well, it fired once. If we wanted to fire like multiple times, we'll simply just sign it by local, or we would. I create a table here, like local players range. So players in range, player is equal to, or actually players in range tower player will equal to true, and then we'll say while players in range tower dot player true, then not then do sorry we'll do like task dot wait like 5 seconds, so it'll fire every 5 seconds. Put the tower colon fire right here. Then we're going to say tower dot player left colon connects function the player that left. We're simply just going to say if players in range tower dot player, then players in range tower dot player will equal to false. So now if you had multiple towers being created, which I'll get to in a second, you wouldn't have the tower be a global variable in your script. So now we have our thing. I'm just gonna go run to it real quickly so you can see when I enter the range. Oh, we have an error. Okay, what's going on? Oh, what? I put capital P for some reason. What am I doing? Wait, oh, that's why. I need to index it with the player. Whoops. I was doing that wrong for a second. There we go. That was a really silly mistake. Alright, now it should fire at me. No, it's not. Okay. Okay, actually, hold on. I'm gonna do something a little different here because I know the issue, but we're gonna have it constantly like add and destroy towers. So I'm gonna grab a run service here, and we're gonna do this a little differently now. So we'll say run service dot heartbeat colon connect function, and we're going to say we're gonna grab all this here, right? We're gonna take this players in range thing. We're gonna put that up here. And then we're going to say players in range. No, actually, I'm doing this wrong again, actually. Hold on. You want to turn this into a function. So local function tower. So every 5 seconds, it's going to add a tower, and then it'll remove a tower every 5 seconds. So we'll do task dots. Actually, no, what am I doing? I'm like tripping out right now. We're gonna delete this right here. We can create some other values that we're gonna use. So we're gonna have one that has all the towers currently. In this case, we could just use this spawn folder, go and get children, or create our own table, doesn't matter. We're gonna make like an interval, so you can call it local interval. It's gonna be equal to 5 because I want 25 seconds. And then we'll just say local time. And that's gonna be for like what we're gonna like be incrementing by for when we add and remove towers, right? So in our add tower, we're gonna like get our position, or actually we don't even need to, I'm just gonna put that in the function random position. So say local towers is going to be equal to the Tower.new and then the random position, and then our 20, in this case it's the range, and we're gonna put in our towers, the tower that we created, and that'll be added to our thing, right? Now we'll make a remove tower. So local function remove tower, and then we're just going to remove a random tower. So local tower is going to equal to table.remove, and then the towers, and then we're just going to remove the first tower in the position. So the oldest tower actually. And we just want to make sure that the table isn't empty. So if the number of towers is greater than 0 like that, we're going to do this. And if you wanted to, we could make a method for destroying the tower. Like in here, we could have like tower colon destroyed. But in this case, we're just going to destroy the model. So I'll just say tower dot model colon destroy. In this case, we store the model right here. So we're just going to destroy that pretty much. And that'll be our colon remove. And now we'll loop through the game and add our timing. So we're just going to say time. Actually, we need to get the other time in run service. It's important because it'll give us the thing that we're going to add to our time accumulator. So we'll say, actually, you know what? Maybe I should not have made it time. We'll just say it time accumulator because it'll show how much time has accumulated. We're going to add the delta time to it. And then we're just going to say if time accumulator is greater than or equal to the interval here, then we're just going to take out time or set it to 0. So time accumulator will minus equal the spawn interval. I'm gonna keep saying spawn interval, minus the interval. And then we're going to add a tower. And then there's two methods we can do to remove the tower. So we can run add tower and then also remove tower. Because every 5 seconds we're creating a tower and destroying a tower. But, if every 5 seconds we're creating a tower and then removing a tower, there's only going to be one tower. So I'll just put like a task dot wait like 0.05 our CPU time. And then we're going to say remove tower. Because every 5 seconds it'll be added and destroyed. So one tower will always stay on there. So now if I put this in, it will wait 5 seconds and then it spawns a tower. Actually, wait, a tower should be removed every 10 seconds, not every 5 seconds. And then we'll go remove interval equal to 10. So I'll actually just take this out here. Say if time, I'm doing this wrong again, oh my gosh. And then make a separate one for the remove time interval. So we'll go remove time. So remove time. Actually, then we'll plus equal to time. So if remove time. No, not remove tower. Remove time accumulated. We'll copy what we did with the interval. Then we'll say remove time accumulated will minus equal the remove interval here. What the hell just happened? Put that there. And then we're going to run the remove tower. There we go. So there's our tower. It spawned in, as you can see here. And when I walk in range, it's not firing at me. Oh, well, that's because I didn't include the fire out function. Oops. But as you can see now, they're spawning in and they're getting destroyed. So this will like ramp up over time because a tower is only getting removed every 10 seconds. But if we wanted to, we could put some like code inside of here to make it like get destroyed after 5 seconds. So in our add tower, we'll simply just say task.wait 5, and then we'll actually put the remove tower above that tower here, and then we'll just say remove tower, and I can take out this entire block at the bottom here. That's another way you could do it. And then we're now going to connect it to the things here. So we'll now just say tower dot there entered connect function. Here we're gonna do the exact same logic we did before. Local players in range table. Now, as a matter of fact, the tower itself has its players in range in here, so we can just say tower dot players in range. But I don't even think we. No, we do use it. Or well, actually, that just it checks for if there's a validity in range. Never mind. So don't do that. And then okay, actually, what am I doing with my life? We're gonna do the same exact thing basically. So I'm just gonna turn this into not self-dot players. We're gonna do tower players in range, right? We're just gonna spawn a function here to continuously fire at the player. So while players in range player do tower fire at player, and we're going to wait 1 second here, and then we'll say tower dot player left connect function player. And actually, I don't even think we need this because it'll automatically take it out for us, right? Yeah, the players in range player equal to no. So we don't need this. Now, actually, if you wanted to, like in Clash Royale, when a troop isn't in range of the Tesla, it goes into the ground. So you could have a player left thing check here if the player's in range is empty, you could make the hidden Tesla go into the ground. But I'm not going to do that because I don't need this player left function. It'll automatically do it for us. So now I can go and hop into the game and then give it time. And here is our Tesla. And it's going to fire at me continuously. And it's working. The Tesla is spawning and it's firing at me while I'm in range. And I can have it deal damage to me too. And just to clear up this error here you get when the thing is destroyed and fired, is equal to self.model and self.model.beam.position. And that'll pretty much do it for us. So now it's just going to fire at me constantly, and then it's still doing that. Okay, what am I? Self.model and self.model.beam. And that should fix the issue right there. And that's it. Tower system completed. And I added a little extra there too, where the tower will randomly spawn throughout this area here. And it'll shoot at the player. What is going on, bro? What? Okay, I put a Fandra shot in there instead. So that should fix it. Shoots at me. Nice. And it's whatever's going on over here. Okay, that should fix up that over there. Usually you'd want to clean up those bothersome error messages that they don't affect the code. They just like fill up your thing. So you can usually fix that by putting some and checks inside your variables. And this video's gotten really long. It's like an hour and a half already. But I'm gonna edit it to cut it down to like 30-ish minutes. And that's it right there. No, it's not. Oh, holy. I'm just gonna go through all of these little annoying errors and fixing them real quickly. But yeah, as I was saying, a quick fix to a lot of these buggy errors that you get in your output is to simply just put an and statement there, and it'll like clean up everything basically. And probably for the C-frame thing, you could put a check here because and won't work for like all of these. That should fix that. Put an explicit check for the values. Because putting and would only check for the, what's it called? It would kind of evaluate to the last truthy value or the first falsy value. So it would work for two values, like the start position and end position, because the first one would be truthy or the last one would be a false value. But for three, it wouldn't, because there'd be one in the middle. And that's it. And it's firing Addison, Tesla from Clash Royale. That'll spawn on the field. And you could make like more turrets like spawn. Like I could have these like spawn like every 2 seconds, every 1 second actually. Here, every 1 second we'll get a turret that'll spawn in. Hidden Tesla from Clash Royale. So now if I walk into it, I'm gonna get lasered. So I'll have a maximum of 5 turrets spawning in. And you could use this not for players, but for like enemies. Like in a tower defense, you could do that. So yeah, I'm getting beamed right now by Teslas. And it's really great having custom signals because they really help tie a lot of your code together, because honestly, signals are crazy. And I probably should have made signals like a separate video, like, I don't know, like 17.5 instead of all of it in one day, because signals are like custom signals or something I would have put separately, kind of like how frameworks I did separately from a video. But yeah. Just to end off the video, I might as well make the interval like 0.05 seconds, the CPU time. Oh my, that's a lot of Teslas. Oh gosh. Oh my. Yeah, this is something you would want to avoid, having all these parts being created on the server. Because if I turn on the micro profiler here, you can see how much usage we're using here when we're creating all of these parts. Like, look at that. Look at that. We want our average frame time to be 16.66, which I'm not going to talk about now. That's something I don't want to get into. But like, yeah, you would create these visuals on the client. Like, I'm like, oh, that's really laggy. Yeah, I gotta stop it. I gotta stop it. And that's it. We're done with that, you know. Thank you all so much for watching day 17. I'm gonna try and get more 30-day scripting challenge videos in. It's just a lot harder with the thing. So I will have a lot of more time next month though. Okay, thank you all so much for watching.